So let me just start. I'll try to hurry a bit up so that we don't get late for our break. So I work at the Huawei GOSIM Research Center, and previously I was mostly doing more, let's say, low-level stuff in the kernel area and in some synchronization primitives. And since basically the beginning of this year, I've moved into more the upper layer of the OpenHarmony operating system. And one of the projects I've been looking into is basically Servo. Some of you may know Servo. It's a web rendering engine. And in this talk, I'll also generally first be introducing OpenHarmony, but also how we made a Servo run on OpenHarmony and why we think this is interesting. So to start, how many people of you have heard of OpenHarmony? It's more than I expected, but so I guess maybe some more of you have heard about HarmonyOS, and let me start here maybe. So HarmonyOS is basically the operating system that's used on Huawei smartphones, tablets, smartwatches, whatever, and it's already been in the news for a couple of years that it's a completely new operating system, and some of you may have read those articles and also read that it says there that people checked and, well, our Android apps still work. And so maybe the one or the other person wonders, well, what is this? Is it just Android relabeled? And so this is one of the points I'm going to try to clear up today. And starting here, I would say that first, OpenHarmony is definitely not Android and totally unrelated. It's basically the new framework that OpenHarmony, or that also HarmonyOS apps are based on. And one key point here is that you can write an app for OpenHarmony and it runs on HarmonyOS, but also on any other third-party distributions. So basically, OpenHarmony is not just HarmonyOS, but there are also other vendors who are maintaining their own distribution, kind of like in the Linux world. There's Fedora, there's Ubuntu, and in this case, it's mostly IoT vendors or other industrial vendors who keep their own distribution of OpenHarmony and have their special use cases for it that are entirely not smartphone related. So up until now, or let's say up until the end of this year, HarmonyOS has had an Android compatibility layer, which means Android apps actually run on it. And what this also means is that basically if you have an app and you're wondering, should I make it an OpenHarmony native app? Like probably you're going to think, well, what's in it for me? And since if it runs as an Android app, you're probably not going to be very motivated to port it to OpenHarmony. And just bring up, so basically at the end of this year, HarmonyOS will move to the next stage, which basically means that the Android compatibility layer will be completely removed. And this means that basically only OpenHarmony apps will work on HarmonyOS phones. And I'll talk about this a bit later more, but just to know, just wanted to clear up in the very beginning that indeed HarmonyOS is not just Android anymore, but it's completely new, and Android apps will not run anymore. So, and just don't have to worry too much about this picture. Basically, the OS features like everything you would need. So basically, you can create your own device, and potentially port some drivers for it. And then you would also already have all the main things you would need, like a scheduler, some more AI subsystems, some logging subsystems. Basically, everything you would want on a mobile-oriented operating system. And one thing I just want to point out here is that there's also a kernel abstraction layer, which means that you're not, or you don't necessarily have Linux kernel as the basis here, but there's also a LightOS kernel, and on Huawei phones, maybe even also the Home kernel, which is a microkernel-based kernel. So at this point, I want to talk a bit about other OpenHarmony distributions, what they're focused on. So there are very different areas. Most of them are kind of like just starting up now because OpenHarmony has not been around for that long. But there's a lot of third-party vendors who are basically creating their own distributions, and some of those are in the mining area, some of them are in the finance area. There's a project which is focused on bringing HarmonyOS to the classroom and having some educational apps running on it. And there's also some government terminals, for example, like with some face scanning to when you enter a building, or like smart door controls, etc. And so I just want to show the slide to kind of show that it's not just a Huawei project, but there are also many third-party vendors who are interested in bringing their own distribution of this. And this is currently mostly with a China focus, because all these vendors are mostly China, but in Europe we also have the Oniro Foundation, which is together with the Eclipse Foundation and the Open Atom Foundation. They're basically working on bringing this Oniro OS, which is a distribution which is more catered to the European or Western market. And I think there will be a talk about this later today. So I already mentioned that the AOSP compatibility layer will be completely removed in HarmonyOS Next. And there has already been basically a developer preview of this for select invited developers. We're currently only open to Chinese developers since end of last year. And basically, you now have to use the new ArcUI framework, which is based on TypeScript, or like a fork of TypeScript. I'll come a bit later to what the differences are. And it basically means you actually have to rewrite your apps in ArcUI or ArcTS. And of course, this is an important key point for the whole project, because if you actually ship a phone with HarmonyOS Next, then you would expect that your favorite apps are there, right? And one key point is here that there's a huge effort going on in China right now to actually port the at least top 5,000 apps to OpenHarmonyOS, and hopefully this will also bring apart a larger library ecosystem which helps creating new apps. So one other key feature of HarmonyOS Next is also that there's actually a custom kernel, so it's not even running Linux underneath anymore. But still, it's completely compatible because there's a compatibility layer. So that basically means if your app runs for Linux with a muzzle-based libc, it will also it should run on the custom kernel. There are some minor restrictions, some C APIs which are explicitly not made available for various concerns, but I'll come to that a bit later. And yeah, so, but just want to mention, so HarmonyOS Next, the target audience in the first rollout this year will first be Chinese mainland, and I wouldn't expect it to see it on the remaining European or Western phones just yet. So, oh, I actually did not click through, sorry. Yeah, so I already mentioned the top 5,000 apps are in the process of being ported, and this is basically because Huawei did some research and saw that 99% of the time of Huawei phone users spent in 5,000 apps, which is quite significant. And so there's currently a huge porting effort going on with already 4,000 of the top 5,000 apps being ported or already being ported. And the remaining 1,000, there are also currently discussions ongoing with the developers on making it happen. So of course, this is a huge effort, and Huawei is helping out the developers to get it ported. One key thing here, I think, is also to mention that one difference is that in China, the so-called mini apps are very popular, which basically means if you have WeChat and maybe Alipay and with their mini apps or Meituan, then basically these mini apps make already a lot of apps available just because you have this one super app, and in it you have all the mini apps just automatically available if you have the WeChat basically. And yeah, one thing that makes porting maybe a bit nicer is that TypeScript is a language that probably many web developers are already very familiar with, and I'll come to why ArcTS or the flavor of TypeScript that we're using maybe makes it a bit of a even nicer language. So let me talk about, so I want to talk a bit about how developing for OpenHarmony actually looks like. And of course, there's an official IDE, which is basically also based on the JetBrains IDE, which is similar to Android Studio. And currently, the latest release is version 4.1, and it's available from the official release notes. Although the English release notes don't list the download link yet, so I just put the Chinese release notes here and made a screenshot so you can easily find which place you have to click. So basically, if you scroll down to the right section, you will see that there's a link for Windows, Mac, and Mac ARM. And that's where you can download the SDK and the developer, the IDE. Some nice features include that debuggers, of course, included, hot reloading, there's a UI previewer, there's an emulator, and profiling tracing are all directly included. One thing that's still missing is, of course, that the Rust plugin, oh, I made a typo here, sorry, that the Rust plugin is missing. I mean, if many of you have maybe used CLion or Rust Rover from JetBrains, they have a very nice Rust plugin, but yeah, since Rust is currently not officially supported, the Rust plugin is missing, and hopefully that can be added at a later point. So, maybe just to manage expectations, the HarmonyOS Next SDK, as I already mentioned, it's still kind of in developer preview, so once you download it, you can't actually test on your, if you have a Huawei phone, you can't actually test for if the new version runs, because you don't have access to the SDKs yet. But on the other hand, the OpenHarmony situation is already much better, because the 4.1 SDK is freely available to everybody, even outside China, and it can be installed automatically. If you want to develop native code, which could be C, C++, or also Rust, then you should also additionally select the native code, which will install LVM tool chains, etc., so that you can compile. Yeah. And I think here I'll just quickly show you how it looks like if you were to create a project. So basically, you start with a boilerplate project. In our case, we select native C++. We later want to look at Rust code, but well, there is no template for that yet. And basically, once you have generated that project, you get a lot of files. So it's not really, that's what the minimum setup kind of looks like, and I'll explain kind of later what all of this is. And one thing I just want to mention here is that in the so-called build profile file, you can basically switch between the runtime OS, which could be either HarmonyOS or OpenHarmony. This affects the signing of the bundle. I'll kind of later talk about what signing is and why this might be relevant at a slightly later point. And, yeah, already here. So, in theory, OpenHarmony apps can run on all OpenHarmony devices. But, and here comes the but, for security reasons, like apps must be signed, just because you kind of want to know who's the developer, is the package still the same as when it was signed? And of course, this means that which signature do we trust? What's our root of source? And of course, this depends on the OpenHarmony distribution, because we can't have one size fits all. If you like for HarmonyOS, of course, it's a Huawei system, so you would have to trust. So you would trust who Huawei trusts. If you have your own distribution, you would probably want to choose yourself as the vendor who you want to trust. So this basically means you compile your application, your OpenHarmony application once, but then in the end, for supporting different distributions of OpenHarmony, you would likely have to re-sign it for different applications, for different operating systems. And if you're just developing, and for example, your distribution is kind of like a system for a development board, then likely the option is just turned off, and you can just flash away and don't have to worry about this. But in the other cases, you would have to follow the signing process, and this depends on the vendor, as I already said. But if you're targeting HarmonyOS, then actually you don't have to care about this too much. The signing keys are basically automatically generated in the DevEcho Studio ID as long as you sign in. And yeah, for OpenHarmony, again, this kind of you have to manually generate the keys because it's a process that depends on which distribution exactly you're developing for. So let me just talk a bit about what an OpenHarmony app looks like. This is the let's say new stage model. There's also an older model of apps available in the APIs, but that's not recommended anymore and deprecated. So I'll just talk about the stage model. Basically, in the end, what we're going to ship is a whole app, and this can hold multiple, or at least one, HAP. And in most cases, it is just going to be one HAP. So that's currently, we're going to assume you have one HAP. One HAP has basically one ability stage, and this can hold multiple UI abilities or extension abilities. Extension abilities are things without a UI, but maybe you want to keep it separate in a different thread or whatever, different process. And UI abilities basically are, if you have on a phone, in the Recents tab, you can see if you want your app to appear as different apps in the Recents tab, then you would have multiple UI abilities. Most of the time you don't want that, then you just have one UI ability, but with multiple windows, with multiple ArcUI pages, basically. So one window can switch between different pages, and this would be our setup. So in the following, we're basically going to assume we have one UI ability and probably multiple pages. And just what to expect when developing an app, there's a lot of metadata files. Some generic metadata is in the app.json file. There's a package manifest. There's a build profile file where you declare your modules, and then then you have the actual module folders. Most of the time you have just one, and by default it's called entry. And the module looks like this. So basically you again have a package declaration file, you again have a build profile, and you have again this build script called hviger file, where you can write your build script in TypeScript if you like that. And then the important thing here is down below in your module, you have again a JSON5 file for the module description, some resources where you can have your strings in different languages for translating them. And the important part is in the ETS, you have your TypeScript files, and the CPP, you have your potentially native code. Don't try to rename it. I tried renaming it to native because I was using Rust and I thought CPP sounds so C++-like, but that broke the build system. Yeah, let me first talk about the ETS folder. It basically contains the abilities and pages of a module, and commonly you have like one UI ability, and this is written in ArcTS, and optionally you additionally have C++ code, which is built by CMake. So if you do have native code with CMake, then you also have to additionally declare those types in what they are in like in the JavaScript, TypeScript world, and currently you have to keep those manually in sync, and ArcTS can import those. So let me just talk about ArcTS now, because that might be interesting. It's basically a stricter TypeScript flavor, and the goals are that it should be easy to read, it should be performant and efficient, and it should prevent common errors. So let me show you. Here we have some TypeScript. This is regular TypeScript. We have a class person. It has a string in it, but this is TypeScript, so actually it doesn't have to be a string. It could also be undefined. This is also what we see here in line 13. We make new person, and well, name is not set. Then we do body.getName, and this will throw an exception because, well, there is no name. It's undefined. Now in ArcTS, you forced initialization, which is probably not a new concept for most of you, and then that basically means that down in line 15 you don't get an error because name is just an empty string, and that's fine, although probably also not what you want. And the other option in ArcTS is that you use this optional question mark that it can, where you explicitly kind of say it's a string or undefined, and then that also forces you down below in line 16. If you just use getName, you will get a compile time error because it's not initialized, and otherwise you would have to use the question mark operator to propagate the error. And these are the common types of optimizations that have been added to ArcTS, basically that you force all types to be known at compile time. Stuff like any unknown types are just forbidden, and the object layout cannot be changed at runtime. This also means that projects that follow the best TypeScript practices can keep a large part of their code base intact, and it allows the compiler to do many additional optimizations just because it knows exactly what the types are, and it doesn't have to do any runtime checks if something is undefined. Oh no, where did my mouse go? Yeah, I also kept here some links for further reading if you're interested in this. Now, the second part of ArcTS is actually the ArcUI specific additions, because actually you probably want to build a UI. And this is all pretty simple and easy to understand. So here's a small example where you kind of have a text box, and if you click the button, it changes the text of the text box. And I don't want to talk too much about this, but basically you have ArcTS adds additional built-in components, like there's a built-in column type, there's a built-in text type, divider, there's some decorators which you can put, then you can compose different objects into, so you can get a composable UI. Just a quick point here, so what we just saw was a page, and this is loaded from the pageability that I talked about shortly earlier, and in most cases, probably you would just have here a simple, when the window state is created, then you load a content, which is just a page, and additionally, maybe in a real app, you would want to, if it goes to the background or if it goes to the foreground, you want to save some state, restore some state maybe, or those are all things that you can do. But in my cases, I skipped all of that. So here we have a small example page. This is just a minimal ArcTS app, and it does some addition. So currently, this addition is implemented in TypeScript. And basically what it does is you have this text box, and if you click on it, then it increments the number and the text gets updated. And now we have this idea, oh, this add operation, we just assume it's very expensive, we want to do it in native code. I mean, this is of course completely stupid because the call overhead to calling to native overhead is much larger than a simple addition would ever be, but let's just go for the example so that I can show you how it would look like. So basically the code doesn't change much. Just in the first line, you would add an additional import statement where you import something from libentry.so, which is basically just, and then you can use any function that's defined in this shared object. In this case, we defined the add function in the object. And then you can just call that instead of the native TypeScript function. Now let's look at how the C++ code looks like that we have to implement to get this add function. And one thing that you will notice is that there's kind of a lot of boilerplate. If you ever used a Node API, this will look very familiar, except that this is kind of like the way you write it without any macros to simplify it. You have some function which is your raw CFFI, or here you first have the constructor, which is used to register the function at all. Then this is the actual add function, where you don't really get your parameters directly, but you get an environment variable, napi-env, and then you can extract the actual arguments, which makes up most of the function. And the actual addition is down in line 24, where you have a napi create double, and then inside there you have value 0 plus value 1. So as you can see, that's actually quite a lot of boilerplate. Which you can simplify a bit by macros in C++, of course, but I just wanted to show how it looks like. So this is only useful if you actually have something expensive to do. If it's just like a simple add, you probably wouldn't do this. But our later example will be Servo, so there's actually a lot of stuff going on in the native code. And of course, you also have to declare your type for the JavaScript, and one thing that has to be kept in mind is that this has to be kept in sync, otherwise behavior is of course a bit undefined. Now, on the Rust side, of course, there's always macros, which can help, and proc macros are very helpful for this because they can abstract away a lot of way. There's already the existing NAPI-RS crate, which is basically a framework for precompiled Node.js add-ons in Rust. And with a couple of modifications, we can get this to work for OpenHarmony. It's not a lot, but it's, we also haven't tried merging it upstream yet. And it's currently a community-maintained fork. I don't really have any official affiliation with it. Yeah, and it's currently in, I would say, in a very early stages of development, but it actually works quite fine. And this helps us to significantly reduce the boilerplate, and actually we can add it quite easily to our project. Now, how can we actually integrate the Rust library that we've built? So basically, the easiest way is we can just pre-build it manually and place it under a special kind of path where the IDE will look. And you could then set up your IDE to call cargo build and copy it. I mean, it's not really my favorite approach, but it works. You could write a plugin to the Schwender build system in TypeScript. I didn't try that yet, but it's definitely possible. Or since we know that C++ code is built with CMake and that works, we could also use perhaps corrosion. Now, as already was mentioned, I actually maintain the corrosion CMake model. It works quite well on Windows, Linux, Mac, and it can basically looks at cargo metadata and then automatically imports any crates that have are either static libraries or dynamic CDY libs with a CFFI. And this works quite well usually. It sets automatically the correct linker and the Rust compiler target, so it's and it does a lot of more stuff under the hood for you. Well, now, one thing that makes it a bit more complicated is that the OpenHarmony SDK ships a pre-built CMake version, which is rather old, and that's kind of missing a required feature, which is to move the, or which corrosion uses, and which would be to move the library to a place where you install during the build. Now, of course, you could backport this to the older corrosion version, but that would also be a lot of work. Other than the other alternative is to use upstream CMake, but that also doesn't work quite out of the box. You basically have to copy one file from the shipped CMake version to the upstream CMake version, and then it actually seems to work just fine. But in conclusion, currently there's the best or most reliable way is to actually add a build script to your IDE or whatever, and that you can just copy it to the hard-coded library path. Yeah, so let me just speed up a bit here. So we have first example that I want to show is basically actually compile something useful, which would be like ripgrep. It's like a simple command line application in Rust. And so we just try to compile it. There's this tier 2 target, AR64 unknown Linux OHOS, which is now shipped as a tier 2 target since Rust 1.78, which just came out a couple of days ago. And well, of course, it doesn't just work out of the box. You first have to add the target. That's easy enough, probably. And next step is that linking fails. We look at the error, and we see, oh, it uses user bin LD. That doesn't look right. So we actually have to specify the linker. And once we specify the linker explicitly via a magic environment variable, I'll come to that a bit later, we can just, it compiles. We flash it onto the phone, and we check, and it actually works just fine. I also did some more tests if it actually grepping works, but I didn't include a screenshot of that because I wasn't sure if maybe some sensitive data wasn't there or not. Sorry. Now, finally to the main stage, ripgrep is maybe not that interesting. What about something a bit bigger? Now, in this example, I'll be talking about Servo. It's a rendering engine written in Rust. The main Servo components measured about 240K lines of Rust code. I measured that with SCC. And that's not amazingly much, but it also has a lot of dependencies. So if you look at the dependency list, it has over 700 plus Rust and C++ dependencies. And then I just tried to use cargo vendor and count how many lines it is. So in this case, I basically did cargo vendor, removed all these Windows crates, WinAPI, Windows, and NDK crates, which brought the line count down by about half. And we see we have about 4 million lines of Rust code and over 1 million lines of C and C++ code each, which is quite a lot. Now, our hope is, of course, that this will just work out of the box. And one challenge here is, of course, that there are multiple build systems involved, CRS, CMake, AutoTools. So we'll see in a moment how that works. The good thing here is that on the UI side, well, for a browser app, you actually don't need much. You need kind of like the browser window where you see the window, and you need an URL bar. Everything else is kind of like not so important, you could say. You don't need a back button, you don't need a forward button. You can skip that for a demo. So maybe as a step how to get an estimation how much work is actually needed to create an app or to port an app. We follow some simple steps. So first we just kind of create a dummy library that depends on libserver, which exposed all the libraries. And we fix all the compilation and linking errors. And so step one here is kind of like figure out all the environment variables which are needed for building the C++ dependencies, because you have to set stuff like the C compiler, the C++ compiler, the linker, PKG config, and all that other stuff. And step two would be then to do the same for like the Rust dependencies, which are failing to build. So one thing that came up here is that often actually the issues were already fixed by the community members. Great. You know, like it was often something like in Nix or in libc where some functions were missing, and all you have to do is update the dependency. Sounds easy, right? But of course, as it turns out, updating long dependency chains can be quite time-consuming. I didn't actually have to do all of that. There are also other people who have to update dependencies from time to time, so a lot of the time was just me waiting on the actual pull request that somebody else was working on to go forward. But of course, since the dependency chains can be quite deep in such a large project, it just takes a lot of time until the bump from a project like 5 levels down gets propagated all the way up, because in the end, oftentimes you have to actually update versions in sync, because you don't really want to have different versions of the same crate multiple times in your project. Yeah, but since we kind of like want to actually make progress and not wait 3 months, sometimes you can just kind of like backport an OHOS, like a fix to an older version of a crate, and then use the patching of cargo as a quick band-aid solution, so that you don't have to update all the other stuff which is completely unrelated to what you actually wanted to do. And the final thing is that sometimes you actually have stuff which needs to be implemented differently for OpenHarmony, like what is a window in OpenHarmony, how large is it? And well, as a first step, you just stub it, write an unimplemented or to-do, and this will fix the compilation error, but of course it will fail later at runtime. But first we kind of want to find out how much work is it at all. Now, once you have all the compilation issues fixed, you can move on to the linking issues. And often there, the fix is just build the library from source. Like it's not available as a dynamic library on the system, but you can of course build from source, and then the linking issue goes away because it's there. And sometimes it's also just that wrong dependencies get linked in. So one thing here was that, well, OpenHarmony targets, the target OS is Linux. So some crates just assume, well, X11 or Wayland must be there, but it's not. So then you have to go and fix it. So yeah. Now after that step, this one I'm going to skip over. It's basically just a list of magic environment variables here and on the next page. Just one thing I want to mention is that if you use bindgen, you should really have a look on both setting libclang path and clang path, both of them. Otherwise, you'll probably run into a bindgen issue, potentially, depending on how many clang versions you have, where one part of bindgen loads the most recent version of clang, and a different version loads the default version of clang. And if those aren't the same, then you can have like weird errors. Like ideally, your compilation fails and you notice. Otherwise, you might have other issues popping up. It took me a while to figure this out because And yeah, let's get skip over that. It's not so interesting. So now we have it compiled, everything links, we can flash it on a device. But of course, in step one, we fix a lot of issues just by writing to-do. That means, of course, it will panic when we hit those. So the first step is kind of like fixing those parts as we hit them. But we don't actually have to fix everything at the beginning, right? We can just hard code some values like this helps in surprisingly many cases, but not in all cases. Like I tried hard coding the window size, but I didn't know the actual window size, so I just wrote 100, 100, and thought maybe it will just render to a small surface, but no, it just crashed. So it can work, and it saves you some time, but not in all cases. So sometimes you actually do have to do it properly. So on this point, I just want to shortly talk about the ArcGIS component. This is basically what is used on OpenHarmony to render to a native window. And now in the simplest case, you just create one X component, and then you can natively render to that. On the native code, which you see down at the bottom, you basically get a no-mangle C function, which it's called onSurfaceCreated, and this gets called when the surface is actually created, and this is then our entry point into Servo. First step is actually getting logging working, because if logging doesn't work, then you also don't see any panic messages, and it's kind of hard to debug anything. And actually, once we hit this phase and logging was working, there was only like very minor changes needed. So basically just during the graphics initialization phase where you had to set the window size, set up the EGL, there were some minor changes required. Most of it could just be done very quickly. And after that, Servo loaded and rendered actually just fine on the first try. Like I was astounded. But of course, it doesn't really stop there. This was simple demo, and touchscreen support was, for example, not there just because I was not listening for any touch events. So, I mean, then you have a browser, but you can't scroll or anything, so that's kind of like not so impressive. Now, can I actually move this to the other screen? Oh, yeah, I can. So I just want to show that it actually works. This is my phone mirrored, and it looks kind of laggy here on the big screen, but on the phone it looks more fluid, so feel free to try it out later. I mean, it's still one thing that is different here compared to, or like still missing, is Fling support. I don't know how many of you know what Fling is, but basically if you scroll on your app and you lift up your finger, then you expect it kind of to go on scrolling, but there is like no native API for that yet, and basically you just have the raw events. So if you lift up your finger, you will get no touch events anymore. And since I don't keep track yet of the history, don't calculate the velocity or anything, it basically means the window stops moving immediately, which is not how you want a browser to be, but for demo purposes, it's just fine right now. Now, how do I move it back? How do I close the window now? Okay. Yeah, so there are some minor things that are not working yet, which is mostly WebGL support. I just disabled it because it led to it crashing, because I didn't implement the part yet where you have an off-screen buffer. Fling support is missing, and actually calling back to the ArcGIS, ArcGIS UI is not working yet. So basically, if you click on a link, it will not update the link, and it won't go to the new website. But those are all minor changes, and I hope to fix that and also upstream the changes to the main server repository. If you want to have a look at the sources, I put a link in here to both the ArcGIS app and my branch of Servo, so that you can have a look at the changes required if you're interested. Just be aware that it's not production-ready code, and there are kind of parts where code is commented, copy, pasted, and yeah, so it's not beautiful to look at. Now, just as a summary of what the changes that were required, the ArcUI to libserver layer was actually incredibly easy, also because of the trait system, so you just have to implement some traits for the callback, and you can also just implement those as no-ops and leave it for later. The OS-specific window initialization was a bit more challenging. The documentation there could also be slightly improved, in my opinion. In general, the documentation for OpenHarmonyOS is quite good. But here in this part, I felt that it could be slightly improved. Yeah, font loading had to be adapted because fonts are handled differently on OpenHarmony as compared to compared to both Android and Linux. So currently I just actually hard-coded a font. Luckily, HarmonyOS uses, or OpenHarmony uses Huawei HarmonyOS font, and that supports, I think, 100 languages, they claim. And so that works quite well for most cases. And getting the rest running is on my to-do list. So yeah, environment variables, figuring those out took a bit of time. And of course, once I got running on Linux, I also tried on my Mac. But it didn't work, of course, and I had to do some adaptations for Mac just because things were a bit different to get it compiling there. And yeah, the other thing was creating Rust bindings for some OpenHarmony APIs, but we have nice tools there like BindGen, which can generate a lot of the code. And then the main thing is kind of like to create a safe layer on top of that, and that's also currently in progress. Main thing here is the logging system HiLog and the tracing system HiTrace, which is needed so that you can integrate into the profiling system of the ID, and you can kind of see where is time spent, how can we optimize it. So yeah, in general, Rust on OpenHarmony is actually quite well supported. It's now a tier 2 target. There's still some manual work involved. It's similar to Android. You have to download an SDK. The standard library is pre-built. You can just add it via rust.target add. You currently still have to set the linker manual via this variable cargo target, and then the target and linker. I hope that in the future this can be set automatically, since technically we actually know what the linker should be if we know the C compiler. And yeah, cross-compiling works surprisingly well. I mean, I mentioned already Servo is a huge project. It had 1.3 million lines of code, C++, and then same amount of C code. And compared to that, the time I spent fixing stuff, I mean, for C code, it was only setting magic environment variables. And for Rust code, it was also not much. Yeah, so this is kind of like, if you have those magic environment variables, then it actually just works. In some cases, like there are some build systems which try to detect the target and be smart, and if they detect something they don't know, like the target called OHOS, well, they just fail, and of course that has to be patched. You don't get around that, but luckily those are a small minority of projects. Now, future work, I hope that we can make Rust really like a first-class citizen for OpenHarmony code, get the macros working, merged upstream, make more bindings so that you can access all the OpenHarmony APIs in a safe way. One important thing is definitely getting a reusable GitHub CI action so that you can tell people, here's a CI action. It actually builds for OpenHarmony. It runs in QMO. You can test it yourself. You don't have to trust me. And another thing I would like to explore in the future is basically integrating async runtimes like Tokyo with the function flow runtime kit, which is used for C++ coroutine-based scheduling on OpenHarmony, because currently you have a situation where you have like both runtimes there, and it kind of means you have double the threads, and it just wastes resources. So ideally, we would only have just one of those. We'll see how we can explore that in the future. So, sorry, I went a bit over time. I'm happy for any questions. And
great, thank you.
Yeah.
Thank you, Jonathan. Let's take one or two questions from the audience. Any questions for Jonathan?
So how easy is it to get OpenHarmony running on a VM or something so I can test things locally?
So that's a good question, actually. I haven't tested this myself too much because I usually use the HarmonyOS emulator, which ships with the, since I actually have access to the new HarmonyOS SDK. Supposedly, it runs very well in QMO. At least that's what people from Shanghai University have told me, because they are not employed at Huawei, they don't have access to it, but they're using it just fine on QMO, and I'm hoping I will actually get the instructions from them how to use it, because they as someone who's working in Huawei, I often only know like the HarmonyOS way, and it's sometimes hard to figure out the way how it's meant for people who don't have access to the HarmonyOS specific stuff. So. But at least they told me it runs fine in QMO, and I'm hoping to get the instructions, and I would also be happy to share it, and I'll That will be part of the thing that will be put into a reusable GitHub CI action, basically. So, yeah.
Okay. Any other questions?
So, is there any way to do native UI, like apart from the ArcTS framework, or is it only possible to do it via ArcTS?
So, I'm not 100% sure here. So I think currently the first class citizen is definitely ArcTS and ArcUI. Of course, you can do rendering via OpenGL or Vulkan for like an X component. When I asked, I was told that it is also possible to create like an app without any ArcTS, but when I asked the follow-up question, I didn't receive an answer yet because there has been vacation basically for the last 5 days. And so I hope I'll get some answers there, but it might be possible, and I'm also very interested in this actually, yeah. But ArcTS is definitely the main native supported way.
All right. Thank you very much, Jonathan. Again, thank you for Jonathan, and we're going to have a break at this time.